What's up, everybody, and welcome back to OpenStax Algebra and Trigonometry, Chapter 10, Section 6, Parametric Equations. Let's do it. Question number 1, what is the system of parametric equations? So in general, parametric equations is like two equations with a third variable. So what you'll normally see is you'll see x as a function of this third variable t. So you might see like x of t is equal to 2t, and then a corresponding y value, but that's also a separate function of t. A lot of times it's time as a different function of t, maybe like 4t squared. So now as t increments, you're getting values of x and y. So for example, when t is 1, you got an xy coordinate of 2 times 1, which is 2, 4 times 1 squared, which is 4. As t is 2, you get 2 times 2, which is 4, and then 2 squared, 4 times 4 is 16 for x and y pairs pursuant to t. That's the gist of it. Done. Explain how to eliminate a parameter given a set of parametric equations. So I'm going to show you by example. So let's say we have x equal to 2t and we have y equal to 3t squared. So what you're going to do is a little substitution, right? We're going to isolate t in this equation. So I'm going to divide both sides by 2. And then once I have this, I can plug and chug, right? I can just swap it in here. And then we have y equals 3 times x over 2 squared. And of course, we can simplify this. That's x squared over 4. So we end up with y equals 3x squared over 4 for the win. That's how you do it. Done. What is the benefit of using parametric equations? So I'm going to go based on what they describe in the back of the book. This is kind of what they posit, and they say, hey, you know, some things cannot be written as functions. One example would be a circle. Now, the reason why a circle can't be written as a quote-unquote function is because it fails the vertical line test, right? So that's not really a function. If we, typically you think about a circle, it's x squared plus y squared equals 9, right? Let's say 9 is the radius. But if you write this as a parametric equation, meaning a separate equation for x and a separate equation for y, in terms of t, once again, we have to bring in that third variable. Now we can have a viable function. So that's one of the benefits. So for this one, we're trying to remove that t variable. So what we're going to do is we're going to do a little substitution. So since I know that x equals 5 minus t, I'm going to isolate t. So I'm going to add t. Here, I'm going to do it like this. I'm going to add t to the left side, and then I'm going to simultaneously subtract x from both sides. So it's going to be t equals 5 minus x. Then I'm going to take this, and I'm going to plug and chug in here. So now I have y equals 8 minus 2 times 5 minus x. And if we want to simplify, multiply by -2, and we get 8 minus 10 plus 2x, right? The negatives cancel out. Combine like terms, and we'll put it in a nice slope-intercept form because this is a line. Y equals 2x. 8 minus 10 is -2. That's how you do it. Done. So for this one, we're trying to consolidate the system into one variable. So I'm going to start with this first equation, and I'm going to isolate t. So again, I'm going to write it as x equals, just removing the x of t. Same thing, we'll just say x equals 2t plus 1, then I'm going to subtract 1 from both sides, and then I'm going to divide by 2 like so. And we got t equals x minus 1 over 2. Then I'm going to plug and chug, right? So now we have y equals 3 times, and I'm going to replace the x minus 1 over 2 with the t, or replace the t with the x minus 1 over 2, I should say. And then we've got this like here, and that's how you do it. Done. So for this one, we're going to do a little isolation. Now, I'm going to actually choose to isolate the y here. I think it's going to be easier because otherwise for this one, we might have to use logarithms. So let's say y equals 1 minus 5t. Same dealio, we're going to isolate the t. So first I'm going to subtract 1 from both sides, and we get y minus 1 equals -5t. Don't forget the minus sticks to the 5. Then we're going to divide both sides by -5 like so, cancels out. T equals this. I can also distribute that negative up there and make it 1 minus y over 5. Looks a little nicer. Then I'm going to plug this in for t, right? Because this is what equals t. And then we get a final answer of x equals 2e to the, and then it's 1 minus y over 5. And that's how you do it. Done. So for this one, I'm going to start with the y because I think it's going to be easier to isolate. So we got y equals 3 plus 2t. Then I'm going to minus 3 from both sides, and we get y minus 3 equals 2t. And then we're going to divide by 2. Boom. And there's our value for t. Now I'm going to substitute this in, and we got an equation of x equals 4 log, and instead of t, I'm substituting this in for t, right? So we got y minus 3 over 2. That's how you do it. Done. For this one, we already got this one almost isolated, so I'm going to start with y equals 2t. Of course, we're going to isolate t, divide both sides by 2. Boom. Now I got this nice value or expression for t, so let's plug it into t here and here in that x equation. So now I have x equals, and I'm replacing t with y over 2, and that value is cubed, minus, again, y over 2. And I could simplify this, but they left it as is in the answer, so I'm going to leave it there too. That's how you do it. Done. For this one, I could choose either equation to isolate. They're pretty similar, so I'm just going to go with the top one, x equals e to the 2t. So let's solve for t. So first, to bring this variable down, I'm going to take the natural log of both sides. So I got ln of x equals ln of e to t. And if you remember your natural log rules, ln of e to some power just simplifies to that power. So now I have ln of x equals 2t, divide by 2, boom, there's my t value, right? Ln of x over 2. Now we're going to plug this in for t, right? Because that's what it equals t. So we have y equals e to the 6 times, instead of t, ln of x over 2. And we're going to simplify this a little bit only because that's what they did in the back of the book. So I'm going to distribute the 6, and then we got y equals e to the 6 divided by 2 is 3. So e to the 3 ln x. And another thing that we can do, which is pretty cool here, is I can use my logarithm rules. Like when I have that coefficient, it's really like an exponent of the argument of the log. The reason why I'm doing that is because another rule is e to the ln of something, right, simplifies to just that something, meaning I can eliminate the e and the ln and just have a nice y equals x cubed. Just refresh your logarithm rules if that doesn't ring a bell. But anyways, that's how you do it. Boom, done. So for this one, I'm going to do something a little different because we got cosine and sine. So first, I'm going to isolate cosine of t by dividing by 4. So I get x over 4 equals cosine of t. For this one, I'm going to divide by 5, and I got y over 5 equals sine of t. Now, the reason why I'm doing this is because this is pretty nifty, because if you recognize with trig functions, I can take sine squared and cosine squared and add them together. And the reason why that's great is because I know what that equals from my Pythagorean identities. It equals 1. So what I'm going to do is I'm going to square both sides. I'm going to say this squared equals cosine squared, and this squared equals sine squared. And then, since I know that sine squared plus cosine squared equals 1, this y over 5 squared, which represents sine squared, plus x over 4 squared, which represents cosine squared, equals 1. And that's how you can get it into this nice xy equation. Boom, done. For this one, again, like 19, I'm going to leverage the fact that sine squared plus cosine squared equals 1. So in this top equation, I'm going to isolate x by dividing by 2, and I got x over 2 equals cosine squared of t, and that's beautiful because we wanted cosine squared. Now, what about this one? I got negative sine t equals y. Well, if I square both sides, I got y squared equals sine squared t, right? The negative, when you square it, it goes to positive. So now I got this really great thing. So now I know that sine squared plus cosine squared equals 1, aka y squared plus x over 2, because again, they're equivalent to cosine squared and sine squared of the same variable, equals 1. And the only thing they did in the answers is they just isolated y squared. So it's kind of arbitrary, but I'll do that anyways. You just subtract x over 2 from both sides. So that's how you do it. Done. So for this one, we got x equal to t minus 1. Of course, if I add 1 to both sides, I got a nice expression for t, which is x plus 1. Now I'm going to take that and plug it into this second equation. Y equals, and then I'm replacing t with x plus 1 squared. Now, I can leave it as is, but in the back of the book, they foiled it out, so I'm going to do that as well. So x plus 1 squared gives us x squared plus x, which is 2x. And if you remember why that is because this is really x plus 1 times x plus 1. So we have to FOIL. X squared, 1x, that gives us the 2x. And then plus 1 times 1, which is 1. That's how you do it. Done. So for this one, we're going to start with the x because it's easier to isolate. So we got x equals 2t minus 1. I'm going to add 1 to both sides. X plus 1 equals 2t. Then we're going to divide by 2. And now we got this nice isolation of t. T equals x plus 1 over 2. Now let's plug and chug into the second equation. So y equals this value, which equals t, so I'm going to slide it in for t, x plus 1 over 2, t was cubed. Now this expression is cubed minus 2. And that is how you do it. Boom, done. So here they want us to convert it to what's called Cartesian coordinates, but they want to do it using a XY table. So I'll show you how to do that now. So if we have an XY table, and we also have to have something for t, we can start plotting out some XY coordinates. So arbitrarily, I'm going to choose 0, 1, and 2 for t. So we're going to get some nice XY coordinates. So when t is 0, we get 4 minus 0, which is 4 for x. 3 times 0 plus 2, which is just 2. When t is 1, we get 4 minus 1, which is 3. Plug in 1 here. We get 3 times 1, which is 3, plus 2 is 5. And then when we got t for equals 2, we got 4 minus 2, which is 2. And then 3 times 2 is 6, plus 2 is 8. So what we can see with these coordinates is we can now see that it's a nice linear equation, and every time x goes down by 1, y goes up by 3. Well, that sounds like slope, right? Going a rise of 3 and a run of -1. Hence, a slope of -3 over 1, or -3. And we also know that we have several other coordinates. So using point slope, I can construct the equation y minus, let's do 2 and 8 just for fun, y minus that 8, which is the y value of that coordinate, equals slope times x minus the corresponding x value, 2. Distribute, y minus 8 equals -3x, and then -3 times -2 is +6. Last but not least, add 8 to both sides, y equals -3x plus 14. So that is how you do it, done. So for this one, once again, we're going to make an XY table and use that to come up with the equation. So I'm going to set that up now. So I'm going to choose a few different values. One of them is going to seem a little bit strange, which is 1/4 for t, but there's a reason why I'm choosing that. I'm going to explain it in a second. And then I'll just choose like some other random values. I'll choose maybe 0 and 1. Those are both easy to calculate. The reason why I'm choosing 1/4 is because I know that 1/4 is going to give me a 0 value for x, which is great because that's my y-intercept. So if this is a linear equation, then that's going to make it really easy to create our xy equation. So when I plug in 1/4, it's 1/4 times 4, which is 1 minus 1 is 0. 1/4 times 4 is 1 plus 2 is 3. So there's my nice y-intercept. That's beautiful. Now let's plug in 0. 0 minus 1 is -1. 0 plus 2 is 2. Plug in 1. 1 times 4 is 4 minus 1 is 3. 1 times 4 plus 2 is 6. So look at these great values. So we can calculate the slope, right? I see that as the y is going up by 4, that's rise, the x is also going up by 4. Very interesting. So it looks like we have a nice slope of 1 and then a y-intercept of 3, which means our equation is y equals 1x, or just x, plus 3. That's how you do it, done. So for this one, we're meant to turn this into a set of parametric equations, or a system of parametric equations. And it's really not going to be too crazy because right now y is a function of x. Instead, we want y to be a function of t as well as x to be a function of t. And a way to kind of seamlessly get this to where we want it, just make x the same essentially as t, right? So we almost have just a one-to-one nice relationship, x equals t. And then I take this equation, it was a function of x, now we're going to make it a function of t, but since x essentially equals t, look how nice this is. I just basically say, hey, it's the same as 2 sine of, replace x with t, plus 1. And this would be the system, boom, done. For this one, since we have x as a function of y being shown, I think the easier thing is to set y first and make y y of t just simply equal to t. And that's really nice because then, since this is solely a function of y, well, look at this. Now I have x, same thing as a function of t, but everywhere where I have y, replace it with t. So square root of t plus 2t. There is my nice system of parametric equations, done. So for this one, we're trying to get this into the nice parametric form by recognizing that x is going to equal a cosine of t, and y is equal to b sine of t. So again, we're going to leverage this idea that sine squared plus cosine squared equals 1. So first, I'm going to isolate cosine and sine in both these equations. X over a equals cosine t, and y over b equals sine t. And then I'm going to square both of these, right? I'm going to square this and this, square both sides, and I'm going to square this and this. And now we're in a really interesting spot, right? I have cosine squared t equals x squared over a squared, and then I have sine squared t equals y squared over b squared. So now since we know that sine squared plus cosine squared is 1, then this plus this should also equal 1. And we already have that here. Look, we already have x squared plus 16 plus y squared over 36 equals 1, meaning a should be 4, right? Because a squared would be 16. So we can kind of write that in here, boom. And then b squared should be 36, meaning b is 6. So we'll put that over here as well. So if I rewrite this now, where I know that a is 4 and b is 6, we can go back to this equation. We can say, cool, x of t is 4 cosine of t. Y of t is, again, we said b is 6, 6 sine of t. And just in case you're wondering what this is, if you recall from our equations for conic sections, this is actually an ellipse, okay? So it's an ellipse. Those are the equations. That's how you do it. Done. So for this one, we're trying to make the conversion to parametric equations using these two equations right here. Now, we have this really cool thing, right? X squared plus y squared equals 10. But what would be better is if we had something squared plus something squared equals 1. So I'm going to divide everything by 10 first of all. So we got x squared over 10 plus y squared over 10 equals 1. So now we have kind of what we're looking for here. And once again, when we isolate cosine of t and sine of t and we square them, and the reason why we do that is, again, we're leveraging that idea that sine squared plus cosine squared is 1, right? So we get x over a squared equals cosine t squared. If you're not sure, again, how I did that, I divided both sides by a, and then I squared both sides. Same with this. This becomes y over b squared equals sine squared of t, right? So now we're in this situation. I know that sine squared plus cosine squared equals 1, and it's basically equivalent to these, right? So this would be, x squared over 10 is the same as x squared over a squared. Y squared over 10 is the same as y squared over b squared, which means that a squared links up with 10. So does b squared. B squared also links up with 10, which means a is rad 10, b is rad 10. As such, for our parametric equations, we now have x of t equals rad 10 cosine of t, and y of t equals rad 10 sine of t. And what is this? If you recognize it from the original equation, that's a circle, right? Something squared plus something squared equals the radius squared. So this is a nice circle with a radius of rad 10. That's how you do it. Done. So for this one, we're trying to put this line into a system of parametric equations. And I think what's really important is this section here, right? Because we have x of t, and then we're also trying to get y of t, and we get these correspondence, right? We almost have like a t comma x coordinate. When t is 0, x is apparently -1. And when t is 1, x is 3. So it's almost like we have a linear equation within a linear equation, if that makes sense, right? Like this is my t and this is my x value. So I can use this to come up with an equation of x of t, right? So, and there's two ways to do, two things we have to figure out. First, we have to figure out the slope by subtracting down, right? -1 minus 3 is -4, over 0 minus 1 is -1. That's a slope of 4, okay? Because this is a nice linear equation here as well. So we have a slope of 4, and then look, we get a t-intercept, we could say, of 1. So the x function would be x of t equals 4t plus 1. Boom. What about y of t? Well, we can do something similar, but we're going to have to do t and y coordinates. And I know that when t is 0, the corresponding y value is 0. That's pretty cool because that's a nice 0, 0 coordinate. And then when t is 1, we know that the y value is -2. So now I can come up with an equation here, right? I see that I have a y-intercept of 0. That's going to make it nice and easy. I need the slope. Subtract down. 0 minus -2 is 2. 0 minus 1 is -1. So my slope is -2 times t with the y-intercept of 0, so I don't even have to add anything. And this is my system. That's how you do it. Done. So for this one, once again, I'm going to kind of make different tx and ty coordinates based on this information here. So for my tx coordinates, I see that when t is 0, x is 4. And when t is 1, x is 6. And then I'm going to come up with my equation. First, I'm going to calculate the slope, subtract down. 4 minus 6 is negative 2 over 0 minus 1, which is negative 1. So we got a slope of 2 for x of t, so it's 2t. And what's my y-intercept, or t-intercept, I should say, well, actually, x-intercept when t is 0. And when t is 0, x is 4. So there we got that nice equation. Now, what about for y? So let's get these. T is 0, y is 1. And when t is 1, y is negative 2. All right, so let's calculate the slope. 1 minus negative 2, which is 3, over 0 minus 1, which is negative 1. 3 over negative 1 is negative 3. So we got a slope of negative 3t, and then my t-intercept, or y, y-intercept, whatever you want to say, when t is 0, y is 1, so that's a plus 1. So that is how you create the parametric system. Done. So for these questions, we're going to use a graphing calculator, and instead of using the table feature, I'm going to show you how to actually graph parametric equations in Desmos. It's pretty cool. So we're going to first graph this one. X is t squared, y is 2t minus 1. So if you see over here as a xy coordinate, I put the x function here, t squared, the y function in the y spot, 2t minus 1. And then you can adjust the t value, right? I can make this go to 20 to 30, whatever, it doesn't matter. But let's just say from 0 to 10 for t. Now for the next one, it's x equals negative t plus 6, y equals t plus 1. So we got negative t plus 6, and for the y, we have t plus 1. And we're going to extend this one out as well to 10, 0 to 10. And look at that. They intersect, right? Where do they intersect? We intersect when x equals 4 and y equals 3. So we got x equals 4 and y equals 3. But what t value do they intersect at? Well, I can take this and plug it into either of I can take this one and plug it into either of the x, or take this and plug it into either the y to solve for t. So let's just randomly take 4 and plug it in for, let's plug it in for this one. So we got 4 equals negative t plus 6. So I'm going to subtract 6 from both sides. Negative 2 equals negative t, aka t equals 2, right? Negate, negate. So that is the answer. That's where they intersect. Done. So for this one, it does say to use a graphing calculator to complete the values, but I think we can do it pretty easily by hand and mentally. So I'm going to do that for you now. So for the x values, I'm going to plug in 1, 2, and 3 for t. When I plug in 1 squared minus 4 is negative 3. 2 squared minus 4 is 0. And then 3 squared, 9, minus 4 is 5. For the corresponding y values, I'm going to plug in 1 for t. 2 times 1 squared is 2, minus 1 is 1. Then I got 2 squared is 4, times 2 is 8, minus 1 is 7. Last but not least, 3 squared, 9, times 2 is 18, minus 1 is 17. So that's how you do it. Done. So for this one, we want two different sets of parametric equations. Obviously, the first one I'm going to do is the easy one. I'm just going to set x of t equal to t, and then y of t literally is the same, right? We're just replacing every instance of x with t, so it's now t plus 1 squared. So for the second one, I'm going to use one that they have in the back of the book. I'm going to set x of t equal to t plus 1. Okay, so this is pretty cool because all I have to do is sub this in here, and I got my nice y of t, right? So now I have y of t equals t plus 1, which simplifies to t plus 2, and that is squared. So those are your two systems. Done. So for this one, we're going to start with the easy system of parametric equations, where I'm just going to set x equal to t. So we got t squared minus 4t plus 4. Okay, now let's do a second one, and I'm going to do what they did in the back of the book. I'm going to say x of t is equal to t plus 2. Now the reason why this is great is because this can also be factored into y equals x minus 2 times x minus 2, or x minus 2 squared. So that makes it easy, because if I'm now going to substitute this in for x in here, right, watch what happens. We get y of t equals, so then it's t plus 2 minus 2, which is just t. So then y of t is just t squared. So that gives us a really nice system, and those are the two examples. Done. I hope you guys enjoyed this video, and if you did, please click that like button. If you want to see more from the Scalar Learning channel, make sure to click subscribe. Thank you guys so much for joining, and I'll see you in the next video. Take it easy.